Hello, I'm Jason. I'm a game developer. I recently released a technical demo that is a fighting game, which, by the way, you can go play right now if you go to my portfolio website. The link is in the description. It was built completely from scratch, with literally starting at an empty project with nothing but the Godot icon in it. Every single line of code was written by me, with no outside libraries or assets used, which by the way amounted to around 9,000 lines of code. Because, as you will hopefully see during this video and learn, I'm a solo developer, which means I need to focus on my program's architecture and design so that things remain stable. That means I fancy myself a data guy, a communications guy, someone who looks at the bigger picture of the whole project and says, how do I make these things communicate in the most flexible way possible? And while for the most part that might seem unnecessary, especially when it comes to the smaller gameplay details of just communicating with the player's inputs, I find it endlessly fascinating, and hopefully I'll be able to show that off to you with this video, and future ones too, as well as the strengths and potential drawbacks that might come from programming in this way. Now, as you may have guessed if you've ever done something like this before, this means I spend a lot of time in pre-development, working on technical documentation. Regardless of the form it takes, it's all about the way systems communicate with each other. How do I get the player controller to talk to the fighting manager in order to allow for rounds to end properly? Or how do I spawn a character in, set its relative data, and then allow the player to control it after? Those are just examples, but regardless, it is a lot like that. Connecting the lines, the dots, putting things together in ways that are decoupled but also able to communicate strongly and send the data that's necessary in order for the game to function. On the flip side, when it comes to actually working on the game proper, I spend a lot of my time in the text editor, programming, simply putting code on the screen, new lines, new functions, new signals, whatever it might be, making sure systems communicate in the way I envisioned in my documentation. Games are a lot of things. There are 1,000 different professions all coming together to build something beautiful, interactive, and interesting. But when broken down, games are, at their core, interactivity through player input. And so, as the programmer, if you build systems that are too rigid or too use case specific or aren't isolated enough or decoupled enough from their contemporary parts, then you're building systems that aren't flexible, that aren't imaginative and interactive devices for the player. They are literally just gameplay moments that are predefined. Now, I do realize that that was a bit of a tangent, but I want to say this to make it clear to anyone who's interested in me, my content, my games, anything, that I value doing things properly. Okay, let's get back on topic, shall we? Fighting games. Technical demo. How would I do this? So naturally, you look at an empty project and you go, okay, how do I make the game play? Let's make a character move. Well, that's not what I did. I said, okay, because they're going to want to move a character, let's make it so they can remind all of their controls dynamically and have that hook into the runtime input listener. That way, no matter what controls they want, they can play the game properly. This was obviously a mistake. Anyone with half a brain who's ever played a game before, who's ever tried to open a project like this before, would say, I just want to play the game. So, after learning Godot's in and outs and its engine quirks, I took a break after a couple of days of working on this rebinding idea and came back with a fresh perspective. Who would have thought when it comes to problem solving that taking a break actually helps you solve problems? So, I scrapped all that, started fresh again, and said, let's make a character move, shall we? Now, a typical approach, regardless of engine, is load up a player controller, default, whatever, hook it into a sprite or a model, and just check for inputs every frame. This works wonderfully. I mean, as the old game dev adage goes, if it works, leave it alone. But for me, due to my pre-development, my technical documentation, I knew the way I wanted to handle this already. And so we finally get to the meat of this video. Finite state machines. Now that's a big scary term, right? I get it. It sounds alien. Say, for example, using the same idea as before, we want to move a character around the screen. Let's say left and right, with a player controller, just like before. Well, Instead of checking inputs every frame in an update function or whatever, making sure it's left and moving him left, and making sure it's right and moving him right, and whatever, instead we have a state. Actually, we have a few states. We have a neutral state and a walking state. The neutral state, or otherwise known as idle state, is just kind of what it sounds like. When the character is doing nothing and there's no input coming in, go to the neutral state. But I'm getting a little ahead of myself here. First, what do states look like? What do they do? How do they work? So let's take this idle state, this neutral state, for example. How do we get to it? What does the player controller do to communicate with it? Well, think of the player controller as this big brain. Handles everything that the player might want to do, all of its functions and components. When the player controller starts up, it says, okay, start up my finite state machine. As the finite state machine is booting up, it'll check for its default state that you set somewhere else. And in our case, let's say that default state is the neutral. That finite state machine will run itself. Every frame it'll ask for an update from the currently running state, and that's about all it really has to do right now. And to make sure our system is fully flexible and controllable, we only allow our finite state machine to get updates through the player controller brain. So if the player controller says, oh, I don't want to update you right now on this frame, then the finite state machine simply will not update that frame. As the finite state machine goes into the neutral state, it'll ask, okay, neutral state, what do you want to do as I enter? Is there anything you need to set up? The neutral state, usually being quite literally nothing in it, doesn't really have anything important to set up other than input, which I'll cover soon. So upon entering, the finite state machine still asks, hey, current state, idle state. Go ahead, I'm entering you, set up what you need to set up. And every frame, it'll say, hey, current state. Go ahead, update what you need to update. And for neutral state in particular, or at least the way I set up my systems, that means that every state is its own pocket of logic, its own little dimension that's completely decoupled from even its system that's running it. So, upon the character controller entering the neutral state sets up some input listening devices. It doesn't have to update anything, so it doesn't even bother with an update function. But when it finally receives a signal from the input listeners it set up on entry, that left or right was pressed, then we finally move into another state, the walking state. So the next step, logically, is exiting the state. The neutral state is being exited to go into the walking state. So the finite state machine says, hey, neutral state, I'm exiting you. Please do what you need to do upon exit. Then we move into the walking state. All of the same logic from the neutral state and the finite state machine and the player controller brain, all of this still applies to the walking state. In fact, it's exactly the same. But the difference is walking state actually does something. It has a function. So, when the finite state machine says, hey, I'm updating the current state, the walking state checks the player controller brain and says, hey, which direction is being held this frame? And then, using that direction, just sets a velocity. Very simple. And that's the magic of this system. Each state is a pocket of logic that, while it does and has the ability to communicate with its parent or brain or controller or whatever, it doesn't need to. And say we wanted to just delete the state outright. Well, we can, and there would be no drawbacks to doing that. We don't need to refactor a shitload of other code as part of another ongoing update engine or whatever. We can just delete this state and everything else will still run accordingly. Now let's say we wanted to expand this idea. Well, the same principle applies. While we could delete states and nothing would change, we can add states and nothing will change. All that changes is what states are even available. Let's say we wanted to make crouching or jumping or running. Simply create whatever state it is you want, say running, and just add its logic in its own state. Bada bing, bada boom. But Jason, I hear you say, this is an action game. It has combat now. What about actions? Well, for my system at least, I created a second state machine. Same setup as the first. The player controller brain still retains full control over this action state machine as well as the movement one. It's set up the exact same way with a default state. Nothing is different. The only thing that is different are the states within it. Say, for movement, it was walking, crouching, and jumping. But for action, it's attacking, being hurt, being grabbed. And while all of these things are logically different, they are also logically independent. We can just delete the attack state from the action state machine, and the action state machine would still function. The only real issue with having two finite state machines is how do we get them to communicate with each other? If you've ever played a fighting game before, typically what you'll see is that when you're being hurt by a move or an attack, you can no longer move your character or control them at all, really. That would mean, given our logic, that when we enter the hurt state, we need some way to tell the movement state machine to lock out. I decided in my systems that I would use the connecting tissue of the fighting player controller brain to access both state machines, no matter which one you're at. But another way I could have easily done this is using signals. Connect the player controller brain to its action state machine signal so that when it changes to the hurt state, I can simply say, hey, turn off my movement state until the hurt state is exited. And while this would have worked great, it would have gone against my idea of each state's logic being its own pocket where I can delete it and nothing would change. And so, after all this, we have two finite state machines. Movement, focusing on moving the character around the screen and in space, and action, focusing on allowing the player to do combat. It is a little bit more nebulous for my taste, but as long as it doesn't involve moving the character around the screen, then I consider it an action state. Hey, like and subscribe if you think I did a good job and you think I'm cool and funny. I think those things, so I'm personally going to subscribe. Also, make sure to check out my website and play my games and stuff. Thanks.